This video will show you how to take a contingency table in R for a bivariate statistical relationship and then standardize it. I like to think of these bivariate tables as the precursor to more sophisticated analyses or formal hypothesis tests, like for a chi-square test of independence or something like that. So it's useful to start by just looking at the table itself and then standardizing it appropriately so we can interpret the baseline results before moving on to hypothesis testing. So as always in these tutorials, I will be using the 2016 wave of the General Social Survey, so I will just load all that so it's ready for analysis. The convention in R when you're building bivariate tables is they look something like this. So you have your dependent variable first, which we'll call y, and then your independent variable x. And so in this case, the variables that we're going to be working with are happiness level and sex, basically to look and see whether there are differences or similarities between men and women for happiness. It's really a good idea when you're doing these sorts of analyses to start by just looking at the variables of interest independently before putting them together. So here, the name for the happiness variable is just happy, right? And you can see that we have three categories: very happy, pretty happy, and not too happy. And then I'll do another frequency distribution for sex. So just table GSS $sex. And there you go. We have 1,276 men and 1,591 women. To put those together, we would first need to have enough theory to guide us to tell us which is independent and which is dependent. And so here, that's a pretty straightforward thing. We would imagine that one's sex influences their happiness and not the reverse. So you would just type in GSS $happy and GSS $sex. Once you do that and you run it, then you get your contingency table. So this is just a bivariate table, and you can see that it's kind of hard to interpret based on just the raw counts because it's not standardized. So how do we standardize it? The first thing that I recommend that you do is to create a named object for your table. So I will just call it happy tab, just like that. I will say that it gets the result. So I've just made a new table object over there. And from there, you can actually pass the happy table to the prop.table command. So you might have seen that in an earlier video I did in this series where I looked at just univariate statistical distributions and we used prop.table there. You might remember that the way that this works is you give prop.table a table object for it to function correctly. But if we do this, it's probably not going to give us the result that we want, right? Because it's standardizing it somehow, but it's actually using the grand total rather than the marginal totals, which is typically how we would standardize these things. And so what you need to do is tell R explicitly how you would like it to standardize. And the way that you do that in prop.table is by adding an optional argument called margin. And so here you can choose whether to have a margin of 1, which will standardize by rows, or a margin of 2, which will standardize by columns. And so for us, we want to standardize by column, so we put 2. And then if you run that, now you can see that it's standardizing down. So you could compare these percentages if you wanted, and you'll see that it just works. So in this case, around 28.6% of men say that they're very happy, relative to 27.9% of women. So pretty small differences overall. Doesn't really look like there's all that much stuff going on. That's really all that you need to do in order to standardize these tables. If you wanted to convert this into a percentage, you could also do that pretty easily by just multiplying the prop.table object times 100, and then you can convert it straight into percentages like that.